got this picture, Abu Sayyid et al. From his articles. You can see cycle of matrix simulation. You start to design the simulation based on acid-drug interaction and modeling. After that, you implement this simulation design that you have done based on equipment requirement and cleaning up procedure. After you implement this simulation, you go to evaluate this simulation, as we talked about that. By evaluation of this operation, after implementation. By wet listing, production logging, as you did in your company, and reservoir and production modeling. After that, we go through to completion strategy. We review and check day by day our reservoir objective, geological description, and after that, if your reservoir engineer needs any stimulation, put work order. And after that, this cycle is again.
Sorry, we do standardizing, implementation, evaluation. So by evaluation, we assume that already have a baseline of evaluation, right?
Yeah.
So how can we get the two completion? Because in this case, the work was already completed, right?
No. Yeah. You evaluate your results of your simulation. After evaluation, you see the result, you check the result of evaluation with your strategy. If this is okay, you just finish this operation and planning to another operation next month. If it's not okay, based on your evaluation, based on your reservoir description and your reservoir objective, you start to replan to do this operation again because you failed. So you start to do it again.
And the operation of a status.
Yeah. Okay. It's completely related to this section. For stoichiometry of chemical reaction, as I showed this before, we have the two different reaction type here. But due to secondary reaction, as I said here, we need 6 moles of HF rather than 4 to dissolve 1 mole of quartz. So we should consider that, but fortunately, because of the software that we have, software do this for us.
So if 6 moles are required, rather than 4, why in the equation of the 4?
4 plus 6. 2, 6. This 4 produce this SiO4. This SiO4 is reacting with 2 mole of HF. So, for general, you need 4 plus 2 moles of HF. This is it's not very clear from this.
I can't see the mark.
Yeah, but you have it on your hard copy. This is different mineralogies reaction based on different acidizing. Consider it reaction rate limitation. If you have a pressure less than 500 psi, this low pressure is limited your reaction. Your reaction is decreased by this reduction of this pressure. If you have a high pressure, this high pressure gives you an opportunity to have a better reaction between these molecules by decreasing your reservoir pressure. This pressure, this reduction leads to reducing these reaction rates. For temperature, adding just 20 centigrade reaction rates and subtract 20 degrees half the reaction rates. So by increasing your reaction, you're increasing your temperature, you got a better and rapid reaction. These factors, pressure and temperature, besides of contact area and volume of ratio, and formation composition and surface wetting, all of these parameters together controlling your reaction rates. In general, in our reservoirs, we didn't face this problem. This problem is not happened in our fields because because of high pressure that we have. But temperature, it has to be considered. It has to be considered, these temperatures.
Sorry, the temperature is temperature of reservoir fluid or the acidic fluid?
Reservoirs. When you inject,
Reservoir, we cannot control it.
no. It's controlling agent. You should consider it. You should consider, for some cases, if your reservoir is a high temperature, high pressure reservoir, if you face it, just like as Yama one, this is a high temperature and high pressure reservoir, you should know it and consider it in designs. Because of that, you have a high reaction rate. So because of high reaction rate, you should consider it by increasing the concentration of your acidizing. You cannot put 28% of HCl to high temperature reservoir. You should retard this stimulation. You use retarded materials to control this reaction rate.
Because high temperature there.
Exactly.
So high temperature doesn't require high concentration.
Exactly.
Yeah, but ordination has adding 20 acid. How can we add 20 Celsius to the reservoir? We cannot, right?
Yeah.
So it's not in our hand to.
No, each every 20 degree, double your reaction rate.
Yeah.
By increasing 28 degree, your reaction rate is doubled.
Yes, this is in theory.
In theory.
Right, we cannot add 20.
No. We don't.
Just theory.
Yeah, just theory. For comparing that, if you have a reservoir, for example, 4 degree, and reservoir 110 degree and 90 degree. So if you compare these reservoirs, you know that the HCl in this reservoir reacts 2 times more than these reservoirs.
Based on that, less concentration is required.
Exactly. And it had low high temperature and
because we have the factor of temperature.
yeah, exactly. This is a controlling agent in reaction.